Hello again to another Agakala Reacts, and because it's 14th January, and on the 14th January 2008, the Messenger spacecraft performed a Mercury flyby. I'm not sure it was the first one or the last one, but Mercury went there. Messenger went through by the Mercury, so we're gonna watch video from the Astrum, and it's titled "Why is the closest planet also the most difficult to visit?" NASA Messenger Mercury probe. So let's just get into it. Let's learn something new about space.
Thanks to Magellan TV for sponsoring today's video. When mankind first started sending spacecraft out to explore the solar system, the first planet to be visited was Venus, our closest neighbor, in 1962. Next was Mars in 1965, and then Jupiter in 1973. Only then came Mercury in 1974.
Interesting.
And already this order might seem
was looking a lot like suns, not sun.
The closest distance between Earth and Mercury is 77 million kilometers. In fact, it is the closest planet to us on average. The closest distance between Earth and Jupiter is 588 million kilometers, almost 8 times that. And Jupiter was visited again in 1974, twice in 1979, in 1992, in 1995, in 2000, in 2007. Multiple missions were launched to Saturn, Uranus, Neptune, to comets and asteroids, while Mercury got nothing for 30 years.
Is it because it's so close to the sun?
Is this because it was deemed uninteresting? Did we discover everything there was to discover about it with that single first mission? No. The first mission was a flyby and only mapped about 40 to 45% of Mercury's surface. Actually, the real reason is that Mercury is one of the most challenging planets to visit in our entire solar system. Why? Well, Mercury exists in a furnace. Due to its proximity to the Sun, its surface temperature reaches highs of 430 degrees Celsius, so any probe visiting it would need to be highly heat resistant. But that same proximity to the Sun means that any probe launched towards it will accelerate faster and faster due to the immense gravitational pull from our star. Using rocket fuel against that would be like swimming up whitewater rapids. Combating the Sun's gravity required too much fuel for a Discovery-class spacecraft to carry. Slowing down the spacecraft enough to be caught up in Mercury's orbit seemed impossible. But all that changed with the Messenger mission. I'm Alex McColgan, and you're watching Astrum.
So
and
what makes the Messenger different from the other ones?
First and only attempt to place a probe into orbit around one of the hardest to reach planets in the solar system. Weight is a challenging limitation when it comes to spacecraft. The heavier a craft, the larger a rocket needed to get it out of Earth's orbit, and the more expensive everything becomes. Scientists try to keep everything as light as possible to reduce this cost. As fuel takes up precious weight allocations that could go towards scientific instruments, scientists try to only take what is necessary to help them complete their journey. However, for about 30 years, scientists could think of no way to put enough fuel on a probe to get it to slow down enough to enter Mercury's orbit, especially if they wanted scientific equipment on board too. So, after the success of Marina 10's flyby missions of Mercury in 1974 to 1975, Mercury exploration was put on hold. But in 1985, an orbital mechanics expert named Chen Wanyan realized that there was a way of getting a probe into orbit around Mercury that didn't need new technology. Instead, he had worked out a particular route an orbiter could take around the solar system that would slow it down enough to enter Mercury's orbit with only a few course corrections.
Why is it kind of looking like there's some landing
Mercury,
or
the orbiter
dragging
would need to go a longer way.
stuff there?
How long? Under Chen Wanyan's model, a craft would orbit the Sun about 15 times, flying past the Earth once, Venus twice, and Mercury 3 times before finally slowing down enough to enter its orbit on the 4th pass. All these planetary flybys would be essential. By skimming the planet's atmospheres, vital speed could be shaved off from atmospheric drag and due to the gravity of the planets. The entire route would cover a mammoth 7.9 billion kilometers
That's
and would take
interesting.
6.5 years. Chen Wanyan's findings were not immediately picked up, but in 1998, NASA began to take an interest in the idea, and after seeing the feasibility of the route, they launched the Messenger probe in 2004. Messenger, or the Mercury Surface, Space Environment, Geochemistry, and Ranging Probe, was only about 1.8 meters long
Normally.
and 1.3 meters wide, and weighed 1,100 kilograms. This is small and light for a typical NASA mission. Just a comparison, Juno is 20 meters long. Messenger came equipped with a powerful thruster, a ceramic heat shield to protect it from the sun, 2 solar panels, and a whole suite of scientific equipment for imaging and measuring data from Mercury. Scientists hoped to take advantage of this opportunity to learn as much as they could about the chemical composition of Mercury's surface, its geological history, its magnetic field, and its core, among other things. Messenger spent its first year in space making one orbit around the sun before meeting
Amelia is
back
not
up
the cat
again
that wanna
with
be on the
Earth.
lap, so
This gave scientists a chance to test its equipment on a known astronomical body, to make sure there weren't any errors and to make any adjustments as needed. Messenger took some photos of Earth and the Moon, and also tested its other equipment to take readings of our atmosphere and magnetosphere. Fortunately, everything was working perfectly. As it began to head further sunward, Messenger employed a clever technique to help reduce its acceleration towards the sun. It used its solar panels to catch solar radiation, like sails on a ship might catch wind. Solar radiation hitting an object actually pushes it very slightly, while this force is very tiny. Because Messenger's journey was so long, it really added up. Making the most of this phenomenon was one of the ways Messenger saved propellant and decelerated naturally. The next notable landmark in Messenger's journey came in 2006, when it did its first flyby of Venus. Sadly for scientists, this moment came at a time when Venus was exactly on the opposite side of the Sun from Earth, which meant Messenger was not in radio contact.
no.
It did take some photos of the planet, which it later sent, but otherwise it performed no science. However, in 2007, it passed Venus again. At that time, another spacecraft was orbiting Venus, ESA's Venus Express. Messenger and the Venus Express took the opportunity to work together, performing the first ever simultaneous measurements of particle and field characteristics of the planet. But then it was on to the main event, Mercury. Messenger made its first flyby of Mercury on the 14th of January 2008, with everything going smoothly. The same was true of the second flyby. But during the third flyby in 2009, something went wrong. Messenger went into safe mode, which was designed to protect systems on the craft in the event of an error. How disappointing to have come so far, only for the mission to potentially fail during one of the final stages. Messenger remained in safe mode for what must have been 7 hours of stress for all the scientists involved.
Can you imagine?
You see, Messenger had to pass through Mercury's shadow during this flyby, meaning it had to rely on its batteries for 18 minutes. Something wasn't configured right in the power management part of the software. Fortunately, Messenger's computer reset once power from the panels charged the battery, and it was able to continue with its mission, swinging around the Sun one more time before finally entering orbit around Mercury on the 11th of March 2011. Messenger took up an elliptical orbit around Mercury, alternating between as close as 200 kilometers and as far away as 15,000 kilometers. This is because Mercury acts sort of like a giant sun mirror, radiating heat back into space. Remaining too close to Mercury was too hot for Messenger, even with its heat shield, which was more designed to protect it from the sun, 7 times brighter by Mercury than it is on Earth. So moving further away every 12 hours gave it a chance to cool off. Messenger spent the next 4 years in Mercury's orbit, far exceeding scientists' hopes and expectations for the mission, as they had originally planned for it to only last 1 year. Before launch, scientists had hoped that Messenger would take at least 1,000 photos over the course of its lifetime. However, Messenger took over 200,000 photographs,
Wow.
giving us a complete map of Mercury's surface in high resolution and color, as well as photographing nearby comets and other planets. On the 25th of December 2014, Messenger's propellant, so carefully saved up until that point, was finally about to run out. By this point, Messenger was orbiting a mere 25 kilometers from the surface of the planet. Scientists gave the thrusters one last burst to extend its orbit for as long as possible, but on the 30th of April 2015, Messenger crashed into the surface of Mercury.
Oh,
After a journey that had lasted over a decade and had covered literally billions
cool
of
though.
kilometers, Messenger's journey had come to an end. Now, if the science findings of this mission would be something you would be interested in for a future video, please let me know by commenting or leaving a like. I definitely think it's an interesting topic, and I hope you will too. And the adventures
Really?
around Mercury don't end with Messenger. In 2025, the ESA-JAXA joint Bepi-Colombo mission will arrive at Mercury, taking over the reins from NASA. So if you want to know more about this mission before I end up doing a video on it, there's a great documentary on Magellan TV's streaming platform called Mercury or Bust, which goes into detail about what makes this mission special and what ESA and JAXA hope to achieve while there. They claim the Bepi-Colombo mission is one of the most complex scientific missions ever launched, a single spacecraft that will split into 2 spacecraft upon arrival at Mercury.
Huh.
So it's definitely worth learning more about. And
That's
with my link in
interesting.
the description, you can watch it for free, because you'll get a 1-month free trial of Magellan TV's.
No, definitely not valid anymore because it is 2023, almost 2024, and that was published in 2021. So, yeah. Anyway, I think that was kind of cool. The fact that they decided not to, like, just do it because it's gonna go around and then around and around, eventually gonna slow down to just go around the Mercury itself. That's, well, I wouldn't think about it, but I'm not a scientist. So yeah. The other thing is, I was thinking that there would be definitely more, but then the whole thing about being so close to the sun, sorry Millie, so close to the sun and basically being so hot, it just definitely make a big impact on all of the stuff that we can make and send over there. So yeah, but I'm kind of curious now about that other mission now that's gonna land in 2025. So we'll see about that. Yeah. Okay. Thank you very much for watching, and I'll see you tomorrow. Bye.